Hi there, I'm Chad Frischman. I'm the head of research and technology at Project Drawdown, and I'm really excited today to be able to introduce you all to the beginnings of the Drawdown Solutions platform. Over the course of this session, we will get a sneak peek into a new tool that will bring the Drawdown framework and research to a new level by allowing contributors from all over the world to bring together the knowledge, data, and understanding of real climate solutions to help accelerate their implementation. Since 2014, we have been developing a new framework to map, model, and communicate the most substantive global solutions to achieving drawdown, making it possible for the first time to see and compare existing climate solutions as apples to apples to apples across sectors as an integrated system. Many of you may have become familiar with our work at Project Drawdown through our best-selling book called Drawdown, at various events and talks, or through the recent update of our results in the Drawdown Review. What many may be less familiar with is the underlying peer-reviewed research, methodology, and models that comprise the engine that drives all of these communications. This engine represents tens of thousands of person hours of research and model development, the massive collection of peer-reviewed and widely cited data by over 80 researchers from around the world, and a new methodology designed to aggregate humanity's knowledge about real existing solutions and evaluate the climate and financial impact those solutions will have over time when ambitiously implemented. Over the last 2 years, we have been working to translate our Excel-based system into an integrated Python software and code base to be hosted on an open source platform so that researchers and developers around the world can contribute to the Drawdown engine as part of a distributed network. But why create a climate solutions platform? Well, because the problem has been extensively modeled, but a truly comprehensive, unified, and systemic approach to assessing the impact of solutions across sectors is comparatively scarce. And this is exactly what Project Drawdown has done at the global level. Now, this platform will allow us to continually develop, evolve, and get more precise about the impacts of climate solutions and their cascading benefits. Global solutions models, global systems models are useful for showing what is possible to achieve in the future. However, they're less applicable to on-the-ground decision-making. We need tools that are useful and meaningful for people working to accelerate climate solutions at scale. This solutions platform will integrate the drawdown methodology and models for broad use across sectors and different contextual scales. Through the distributed network we're calling the Global Research Collaborative, this platform will allow for the integration and validation of place-based data to be incorporated into the drawdown framework. It will allow us to develop the capability to work within any contextual boundary, whether that's regional or national, local, or even across corporate supply chains and investment portfolios. This open source platform will also act to aggregate and incorporate real-time data from new research recently released for public use and further development for decision makers and stakeholders. We are currently working with developers and designers to develop a web and software platform that will allow researchers and contributors to really interact with the model and data. Eventually, this will include specialized user interfaces to input specifications that can result in outputs tailored to the needs of different stakeholders and different places around the world. But for now, we are still in prototype mode and will continually be developing this platform over the course of this year. But to get a sneak peek into where we are today, I'm going to hand over to our partners at the Colab Cooperative, who are diligently working to develop the code base, the API, and our first researcher interface. Over to you, Ravati.
Hello, I'm Revati and we are Collab Cooperative. We are proud to have been chosen by Project Drawdown to be the lead technical partner to help co create and develop the Drawdown solution platform. As a worker-owned cooperative, we work based on democratic principles, just economics, and an ethos of collaboration across borders. As Project Drawdown's official design and development partner, we are co investing in developing the platform and partnering in the creation of its vision and roadmap. We, as Collab Cooperative, are making a strategic investment in this work because we believe in its tremendous potential, the potential for positive ecological change when we work together as a global research and development collective. We've been building an online scenario modeling interface that connects to the Drawdown modeling engine. The interface can support researchers, municipalities, and businesses in planning investments in renewable electricity generation. There are more models to come in the new year. We're excited to give you a sneak peek of what we've been up to, and my coworker Ethan will take you on the journey. Ethan, over to you.
Hi, my name is Ethan Wynn, and I am member owner of Colab Co-op. I'm also a technical strategist and developer, and sometimes user research support resource for this project. And it's been a real privilege to collaborate with all the wonderful people who are working together to bring drawdowns analysis tools to the web and to support climate researchers around the world with this great framework. I'm going to present a little bit about the features and functionalities of the app that we've designed, show you some of the key screens, and give a sense of what it can do. And then we'll take the prototype that's currently in development for a spin and show you what it looks like. All right, so come on along and let's take a look. The first thing you'll see after you create your account and log into the web application is a listing of all of the workbooks or solution sets that are available for you to use. That starts with 3 core scenarios that Drawdown has curated, made available for anyone to build off of. Each of these is extensively peer-reviewed, and a lot of you are very familiar with all that's gone into making them. So you can start by forking the PDS1, PDS2, and PDS3 scenarios, each of which have different expectations as far as conservative or aggressive estimates of adoption. Once you've forked a set, if you choose to fork one, you'll be able to copy that and create your own name for it, specify the author name, and a note here, about what has gone into the changes that you've made to that base set. As we'll talk about later, the chain of inheritance is kept as folks fork and extend each other's work in ways that enables some really amazing possibilities for collaboration and work together. Once you've started creating your own sets, you'll see those added to your library. And as we build out more collaboration features, you'll also have access to the workbooks of others in your organization or institution, as well as to other workbooks that other researchers have made public that you can search for and build off of yourself. Once you've set up your workbook, you're ready to dive into the process of editing variables and exploring the data. The navigation bar makes it easy to jump between different solutions. When you're in a solution, you can quickly view its adoption cases, finances, and emissions variables. We've worked hard to make sure that the context for these variables is always right at hand. So you have a choice of how you want to go about specifying values. If you want, you can easily directly edit these values to explore different settings and how they impact the outcome of your model. Alternately, however, all of the meta-analysis tables in the Drawdown universe are available for you to choose and explore and use in informing the values you specify. Here we're showing an example of one data source. More could be chosen easily. You can choose whether you want to use weighted averages or not. And then it displays the mean, and one standard deviation, high or low, is adjustable in some cases, that you can then use for your variable values. Ultimately, you'll be able to upload your own data sources, choose specific rows to exclude or include, as well as easily browse right next to this the actual values in the meta-analysis grid. Also present are help icons that give you information about how this variable is included in the projections, as well as a quick bookmark icon that allows you to star certain variables as of particular interest and allows you to edit them from other places. So I might be able to edit, say, the solar farm's first cost value, even when I'm looking at a different sector with just one click. So we hope that this tour around the um, initial prototypes of the Drawdown web app that's in development begin to whet your appetite for some of the possibilities. There's a few more features that are here that are indicated by the current state of the prototype that I think deserve a little bit more mention. The first, of course, is the visualization at the top. That's the interactive data visualization, which right now is showing the basic information about the scenarios in this workbook. So we see the contribution of each sector towards either the production or sequestration of CO2, as well as the thresholds for either if the scenario at a given year has not yet reached drawdown, we see the thresholds for what sequestration would have to be in order to sequester the carbon being produced in that year. Or, as you can see towards the right of the graph, once we've reached drawdown, you can see the amount that's being sequestered in excess of production. Similarly, we have the fingerprint chart on the left, which shows a basic summary of the final state at the end year of this workbook's analysis. And it shows the contribution of all of the carbon sources in the top half and all of the carbon sinks in the bottom half towards either drawdown or the production of excess carbon dioxide. This is a totally interactive graph, and we're really excited to build out additional features that allow you to quickly drill down to specific regions of time, to expand each of those sectors to get more information about how the solutions that in those sectors contribute, as well as to reconcile the two, to quickly understand how the different views into this data relate to one another. So there's a lot going on with the visualization world, and we're really excited to share with you as that develops further the visualization tools that we're building. The second feature that deserves a little more mention is the integration with the data library of adoption cases and market projections that Drawdown has built up and that this platform enables. So currently, we have the ability to choose from very simple drop-downs of available adoption cases for different technologies. And we're really excited to build out additional features to allow you to upload your own adoption cases, to specify more variables in terms of growth and curves and projections and for these adoption cases, and also to compare between even more different scenarios to understand how different scenarios stack up to one another with different adoption assumptions and whatnot, and also to merge back together. So once we've done this forking, to be able to merge back together. And all of this is really made possible because the user interface that we're seeing here, which we've working to make quite simple and easy to navigate has on the back end an extensive implementation of Drawdown's model, and as well as access to the complete Drawdown research library. And that's all hidden and kind of behind the scenes here. And I'm excited to pass it off to David to talk more about that and just recognize all the amazing work that many developers and folks have put in to making this possible. So excited to hear your thoughts, and over to David.
Hello, I'm David. I'm also a part of the Colab development team. I'll be talking a bit about some of the machinery under the hood. So the web application shows researchers an interface to a computation model on the back end, what we would call a customizable simulation. The server is responsible for providing the state of the model to the user interface, and then calculating the model depending on those given inputs. So to do that, the front end first loads up your work from the server. The front end can make edits and then update the server with those edits. The server does the calculation and then sends the results back. So there's a lot of optimization that goes on behind the scenes so that the browser only sends what needs to be sent to the server. We have structured the model as modular linked data, which creates a graph of models and research work. Every time you branch an existing scenario, that link is stored in the database. Every time a projection references a particular adoption scenario or meta-analysis table, that information is also stored as a link. And this is how we enable the intuitive creation of scenarios, and it's how we enable collaboration among the global research community. Separating the data and computation API from the user interface allows flexibility in how we present the model data for a wide range of users. We've started with researchers, but the same engine can be used to support the work of policymakers and many others as new user interface features are built. Linked data allows the community to access each other's data, build on it, and benefit from climate research in different sectors and regions from across the world. I'm excited to see how this Project Drawdown platform will enable this community to impact climate crisis issues.
Thanks, David. We're really looking forward to see how the platform will empower you to take the climate action needed to achieve Drawdown. And we would love your support towards the future phases. As a transnational cooperative, global collaboration is in our DNA, and we're really excited to work with you. Join us in this global effort as new contributors, as investors, as stakeholders. Alden will be talking more about how you can get involved and what's coming next. To reach us at Colab Cooperative, email us at hello@colab.coop or follow us on social media. Thank you.
Thanks, Team Colab. Greetings, my name's Alden Bevington, and I'm the product manager helping to develop the Drawdown Solutions platform. So now that you've had a sneak peek of the platform development and met a few members of the stellar global team, I'm going to zoom out a bit on the platform, process, and roadmap. But first, I want to recognize that every person in this global collaborative has made the commitment to apply their professional skills to fixing the climate emergency. I deeply respect that. Do look up the collabers and the Python team. They are truly excellent. The Drawdown Solutions platform is driven by a timeline that's a little bit different than most other software developments. We're not driven by the desire to be first out in the market or to bring financial returns to our investors as swiftly as we can, or to get all our ducks in a row and neatly packaged up for an exit. We're instead driven by the real timeline of the planet. We know that there are tipping points we cannot cross if we're going to achieve Drawdown. And we know that the sooner we can get this platform built, the better chance we're all going to have. And this isn't hyperbole. The Drawdown modeling tool is the most comprehensive analysis tool available, and yet to date it has not been easily accessible. We need it to be widely accessible. The sooner this platform can be in the hands of users like you, the sooner we can get a firmer handle on the complex tasks we all face. So we're working quite hard on this, and that's our driving timeline. And in a few moments here, I'll be asking for your help and letting you know how you can get involved or support this mission. But prior to that, to give some context, I'm going to give you a lightning speed overview of the software ecosystem and a sense of our roadmap. As was mentioned before by my colleagues, this tool was originally built in Excel. You might have seen it introduced briefly in the beginning of the Drawdown book. Here's some closer looks. To the uninitiated, it is the most mind-boggling application of Excel you're likely to ever come across. Depending on the calculation, the runtime when you press go was between 30 seconds and 3 hours. I have a friend who was on the Excel team at Microsoft for years who laughed out loud at that figure. It's a beast, and there are a few people at this conference who can and actually do use it, and there's an even smaller few who actually designed and built it, so props to them. There were many limitations to the model remaining in Excel, not the least of which were interface limitations, and a process began to take the models and rewrite them in an intermediary code language called Python. This Python translation initiative has been working steadily in the background since September 2019. It's been held down by a small community of developers who are volunteers and lives in a GitHub repository. If you know what that is, please go check it out, and if you feel moved, get involved. Now about 70% complete, the majority of the translation work to date was done on a volunteer basis by a very talented developer from Google named Denton Gentry. If you need a senior developer for climate projects, do look him up. He's pretty great. For now, I'd like to introduce you to one of the developers currently working on the Python code, Dev, who will give you a brief view into what he's been working on. Hi, Dev.
Hi, everyone. My name's Dev, and I'm a volunteer developer for Project Drawdown Research. I want to share a little bit about the work that I've been doing so far and make an invitation for other developers who are interested. First, a little background about myself. I'm a data scientist living in San Francisco, and I work at an AI startup called Noodle AI. We're trying to create a world without waste by using AI-driven decision-making in the supply chain and manufacturing industries. I've been doing this work for about 3 years now, and about a year ago, I started thinking about how else I can make an impact in the climate change space. So that's when I learned about Project Drawdown, and I was really inspired by the work that they're doing, since these models will be touching thousands of decisions around the globe through researchers and policymakers who will be leveraging them. So I decided to get involved and start contributing code. And I want to give a quick example of one of the models that I've implemented in Python. This is the health and education model. It's basically looking at different population scenarios in the future and figuring out how much CO2 will be avoided by the reduce in demand for energy. So over here, you'll see this beautiful Excel model. And we can come with a set of assumptions and input data about the population. And through a series of number crunching and formulas, we get our final result in this top corner here, which is the total amount of CO2 avoided based on different regions and different year ranges. So we eventually want to move away from these Excel models so that they're easier for researchers to interface with and extend. So I've implemented this in Python. And you can see up here we have the same set of solutions and data. But now if I run this script here, you'll see it prints out exactly how much CO2 will be avoided due to this solution. So that's just a quick example of the type of work that we're doing. So far, it's been a really positive experience for me. I feel like I've been able to learn a lot and extend my skills in design patterns, systems thinking, automated testing. And while I'm learning, I get to create something that's of huge value to the world. So if anyone else is interested in helping out with this project, I'd highly encourage it. Send an email to research@drawdown.org. And you can also look up our repository on GitHub. It's called Project Drawdown Solutions. And you can get a quick introduction to the work that's been done so far and some of the upcoming needs. Thanks for listening, everyone. I look forward to meeting some of you in the future.
Thanks for all your good work, Dev. The Python translations of the models and the developer community making them are an essential foundation to the system architecture. Here's a quick view of that architecture. In this image, where you see the words Drawdown engine, that is the Python code. Again, it's about 70% complete. For this, we are seeking volunteer developers to engage in the GitHub repos, and we will be hosting hackathons, also with the Colab Co-op, beginning in Q2 of 2021. In between the interface and the engine are APIs, which on the diagram you can see moving little packets of data back and forth. These are built to eventually allow the Drawdown engine to connect to various interfaces, both currently built and unbuilt. Future elements of the UX, UI, and functionality of the platform will continue to be informed over time by people like you, and we are committed to an iterative, user-centered design methodology. We deeply encourage our platform partners to reach out and get engaged with the development as we progress. This is a hybrid development in that it relies upon both volunteer and funded developers. Though the source code of the Drawdown Solutions platform is and will remain free and open source, as reflected in its AGPL license, the term open source can mean a whole lot of things to different people. This is not a fully volunteer effort, and we don't think that the planet can afford that risk. We need to invest as much resources as we can to complete this project as swiftly and at the highest quality possible. As much work as we can get funded, we will prioritize for that, while filling in the gaps and turbo boosting the timeline with volunteers, pro bono expertise in our working groups, and hackathons. Our limited beta version of the V1 interface, initiated in September 2020, will be ready for some test laps in early February. As mentioned previously, the beta in February will have the electricity generation model fully implemented. The rest of the models, for instance, food systems, land use, ocean, and the built environment, these will be built out in a triage as resources permit. The delivery timeline, like the Drawdown model itself, is thought of in terms of multiple scenarios, which we call the platinum, gold, silver, and recycled aluminum can tracks, each determined by the resources available. One of a number of scenarios we have mapped out is shown here as an example. The recycled can timeline is difficult to determine, as it would rely 100% on volunteers who often have other work commitments to juggle. Silver speed product delivery is Q1 2023, gold speed is Q2 2022. Our most accelerated timeline, platinum, has a full build by the end of 2021 and assumes very few resource constraints. Those resources broadly include financial resources, expert technical support, and volunteer coding support. There are many ways to become a stakeholder. All the code is in an AGPL license, which keeps it free and in the public domain. The platform is a public good, the ROI is a climate in balance, and no one on this project gets equity, just the glory. The roadmap overall is between 1 to 3 years to full build. To complete this important work as swiftly as we can, we ask for financial contributions to support the team, to keep milk in the fridge of the coders and designers, so to speak. Having been deep in the wiring of this tool, we know that the potential applications, features, and impacts of the Drawdown Solutions platform are immense. But in our development, we are focused on putting one foot in front of the other and completing the task at hand while keeping our eye on the big vision. Our global team of collaborators, partners, and community of experts in the Drawdown ecosystem are working every day to make the Drawdown Solutions platform both exceedingly useful and exceedingly awesome. If you would like to support this work with financial resources or with development resources up and down the software stack, including the Python development in GitHub, or know of individuals or organizations that might, please reach out to research@drawdown.org with subject Drawdown Platform. Thank you so much for all your time, attention, and all the good work that you're doing for the planet. Bye now.